Square ABCD has side length 2. A semicircle with diameter AB, so that semicircle is constructed inside the square, and the tangent to the semicircle from C intersects AD at E. What is the length of CE? So what we can do is CE is a tangent, so we can mark the point where the tangent meets the circle as X, and we can have a center of the circle that and call it O, and I can join XO, and then OX would be perpendicular to XC because radius is perpendicular to tangent, and I have to join OC, and you will see that helps me because I know BC is 2, OB is 1. I can find what OC is, and if I can find what OC is, I can also find what XC is. So let me start with OC first, that OC square equals OB square plus BC square, and that equals OB square is 1 plus BC square is 4, and that equals 5. So OC would be root 5. So that is root 5, and using that I can find what XC is, because OX square plus XC square equals OC square, and OX square, I know OX is 1 because it's a radius as well, so that's 1, and plus XC square, we don't know what XC square is, equals OC square, that would be 5. So XC square would be 4 and XC would be 2. So this is the next thing I found, that XC is 2. So once we know that, we have half of what we need. We still need to find out what EX is. How will we find out EX? You see, something else we have to use, one of the other circle theorems, that from the external point E, when you draw two lines touching the circle, the two tangents, these tangents will be equal in length. So EA equals EX. So I can write EA equals EX. Both are tangents drawn from the same point, from point E. So if they are equal, I can assume that this is X, then this would also be X. So EX and equals X. Suppose they are both X. So EA equals EX equals X. Okay, X units or X centimeter, whatever. So that's X. So then what I can do is, if I were to join OE, how does that help? Well, if I did that, do I need to do that? I don't think it's going anywhere. Probably not. I can join it, but I don't know how this will happen. What I can write is DE, you see, will be 2 minus X. So I can use that approach, because if I say D, because we are trying to find out X, and we are going to use Pythagoras to find out X. So that's the plan. So if I use X, yeah, this should work. I don't need to do this, join OE. Don't need to join OE, but if I need, I'll join it later. So then DE equals 2 minus X, and CD is 2. So we can form an equation, the Pythagoras equation, that is CD square plus DE square equals EC square, right? So CD square, I know CD square would be 4 plus DE square would be 2 minus x whole square equals EC square, and that is 2 plus x whole square. So we get 4 plus 4 plus x square minus 4x, not 2x, x square minus 4x equals 4 plus x square plus 4x. So you see the 4x square and one of the 4's and x squares get cancelled out, and we are left with 4 equals 8x. X equals half. So we know that x equals half. So this is half. So therefore, EC would be 2 plus half, because it is XC plus XE, C plus EX, and that would be 5 out of 2. So the answer is D, 5 out of 2.